first, so we can substitute there. That's a plus b whole square, so a square should be 4x plus 2ab, 2 times 2, 4, 6, 24 root x, and plus 6 square is 36, please. That's what we have as the value of y square, and substitute that here, and you're supposed to get the answer. The next part is going to be the differentiation of the parametric equations. Okay, we did solving simultaneous equations. We had one parametric and we had one as the Cartesian. So we changed the parametric one into Cartesian, then we solved those two simultaneously. Okay, so that is done. We are in differentiation now. Parametric equations, how do we differentiate? Our aim is to find dy over dx. That's all in this sum, right? The first one, we use the chain rule that we learnt in C3, and we can use that here to find dy over dx. Let's differentiate this with respect to t. So we have dx over dt is equals to 2t. That's all. And then differentiate that, dy over dt equals to 2. If you divide this by that, you get dy over dx because the dt's cancel out. So that's the idea. So what we do now, dy over dx, the first step, first sum I will do slowly, dy over dt, watch, divided by dx over dt. So the dt's actually cancel out, you'll be left with dy over dx. So dy over dt value is at 2 and divided by dx over dt is at 2t, and the answer is 1 over t, right? We are still in t only, not x and y, okay? But this is actually dy over dx in terms of t. So if you know this, now this is actually the gradient function, right, in terms of t. What if they say find the equation of the tangent at t equals to 2. So you substitute the 2 here in this place, you get the gradient as half. Then to find the equation of the tangent or normal, we need a point and we need gradient, right? Gradient we get here, the point, substitute t as 2 into those two. You will get x and y as the point. We will do few questions of that type, but for the time being, let's just say dy over dx. This is the question. They want us to find the equation of tangent at t equals to 1. We don't have the Cartesian equation, please. We have only these two, x and y. So we find dy over dx. Remember, equation of the tangent. We need a point and then gradient. Let's find the gradient first. So dx over dt is equals to 3t square and minus 2t. That's all. Then dy over dt equals to 2 times the bracket t plus 3. Then times, differentiate the bracket, you will get 1. So we can leave it like that. Then the we are supposed to write dy over dx, please. That's the gradient we need, m, right? This divide by that. So it's 2 bracket t plus 3 divided by 3t square minus 2t. If I take a t common, it's of no use. So let's write 3t square and minus 2t. That's the gradient in terms of t. We are supposed to find the equation of the tangent at t equals to 1. So if you substitute t as 1 here, we will get the gradient. So let's substitute 1 there. So 3 plus 1, 4. 4 times 2, 8 is on top. T equals to 1 here. So 3 minus 2, which is a 1. So it's just 8. So m equals to 8. We got gradient. We need a point. Then we can find the equation of the tangent, right? The general x coordinate is this and general y coordinate is that. If you substitute 1 in both of that, in place of t, you will get x and y points. So t equals to 1. 1 cube minus 1 square should be 0. So I got the first x coordinate as 0. Then substitute t as 1 here. So 1 plus 3, 4. 4 square, 16. Right? So that's all. Now you all know how to find the equation of the tangent. You have done plenty of sums based on that, right? Y minus y1, which is 16, equals to slope times x minus x1, which is 0. So that's the equation of the tangent, please. So we have y minus 16 equals to 8x. If not, y equals to 8x plus 16. That's the equation of the tangent. By the way, if they ask you to find the equation of the normal, you do exactly the same. Once you get the m value, make it upside down and change the sign to find the equation of the normal. Okay? That's the equation of the tangent we have done. Now, I'll give you one more question for you to do. Please copy that and try and solve it. Then you can check the answers. Okay, we need to find the equation of tangent at t equals to 2, please. So find dx over dt. We are finding the gradient, please, is equals to 9 goes off. That's a minus 2t. That's all we have. Let's find dy over dt here. That should be 2t plus 6, right? 2t plus 6. Once you have that, you can write the gradient m equals to dy over dx, please, is equals to that divided by that. So 2t plus 6 divided by minus 2t. If you want, you can make it smaller, right? Divide by 2, 2, 2. But we are simply finding the gradient. So I will leave it there and substitute a 2 there. 2 times 2, 4. 4 plus 6, 10. Divide by 2 times a 2, 4. That's a minus 4. Now you can make it smaller. That's a minus 5 over 2. Correct? So that's the gradient. We need a point. Right? We need a point to find the equation of the tangent. Substitute t equals to 2. Watch the value of t there in place of x. 9 minus 2 square, 4. So that should be a 5. X value. If you put the t value as 2 here, that's a 4 plus 6 times 2, 12. So 4 plus 12 is 16. So that's the point. So we have gradient and point. We can find the equation of the tangent. Y minus y1, which is 16, equals to slope. That's a minus 5 over 2. Bracket x minus x1, which is a 5. And you can do the cross multiplication if you want. That's a 2y minus 32 equals to, open the bracket with minus, just be careful there, minus 5x and minus times minus plus 5 5s, 25. Remember, we moved the 2 to the left hand side. Depending on what the examiner wants, sometimes they want express the answer as y equals to mx plus c, then you make y subject. Here, I'm saying just write in the form of ax plus by equals to c, right? So we keep the x and y on one side, so we will have 5x plus 2y equals to 25 plus 32, which will be 57, okay? So we can leave the answer like that. Just be careful, read the sum, what the examiner wants you need to know. That's it, we got... So we did 2 questions on equations of tangents, right? Here is one question I want you to try. Find the equation of the tangent at t equals to 2. T equals to 2, right? Fractions, well, differentiation, you all know. It's a u over v style, so it's the quotient rule. And that also, once you get those, then you find the gradient. So try and solve that. I'm going to do here. So please check your answer when you finish. So it's dx over dt equals to, that's a u, that's a v. I'll do u dash v, which will be 2 bracket 1 plus t square minus u v dash, u is at 2t and v dash will be 2t, right, times 2t divided by v square. So that's 1 plus t square whole square. Simplification little bit maybe. 2 bracket 1 plus t square and we have minus 4t square there. Well, you can actually open the bracket. Then we have 1 plus t square whole square, please. Let me just do that here itself. 2t square minus 4t square will be minus 2t square. Then 2 times 1, 2, so that's a plus 2 divided by 1 plus t square and a whole square. Listen, this is the dx over dt only, right? We need to find a dy over dt. I will call it u and v. We use the same style. Well, there are so many different methods that you can actually use. U dash v, so u dash should be minus 2t, right? Now this is dy over dt, please, right? U dash v, so minus 2t. V is this, so that's 1 plus t square and minus u v dash. V dash is 2t, so let's write that first, and u comes as 1 minus t square, right, divided by, please understand, v square, so that's a 1 plus t square whole square. That's the idea. I mean, those two actually cancel out when you divide one by the other. Simplification a little bit, please. So minus 2t times 1 minus 2t and minus 2t times 1 minus. So we have a minus 4t. Then this is minus 2t cube and that's plus 2t cube. They actually cancel out. So that's all we are left with, 1 plus t square whole square. Guys, listen, that's a dy over dx. This is, no, dy over dt, please. This is dx over dt. So divide this by that to get the gradient, right? So let's do that. If you divide this by that, do you agree those two cancel out? And you will be left with gradient is equals to minus 4t stays on top and that stays at the bottom, which is minus 2t square plus 2. Simplification, I'm not really bothered because we are finding the equation of the tangent, right? We know that the gradient we can find if you put t as 2. So just right there, m equals to minus 4 times 2 minus 8 divided by 2 square 4 times minus 2 minus 8 and plus 2. The answer now comes down to, that's a minus 6, right? Minus cancelled. 8 divided by 6, which will be 4 divided by 3. That's the gradient of the tangent, right? We need a point now. We have to go and find a point. To do that, you all know, we substitute t as 2 there. That becomes a 4. That becomes a 4 plus 1, 5. So it's 4 over 5. Do you agree with that, right? So x coordinate, guys, 4 over 5. The y coordinate, just be careful, there is a minus sign there. 1 minus 4, which will be minus 3. That's actually 1 plus 4, which is a 5. So minus 3 over 5, please. Let's write minus 3 over 5. We are finding equation of the tangent. We got that. Then we can say y minus y1, which is already minus, so it will be a plus 3 over 5 equals to slope is this 4 over 3 gradient x minus x1 4 over 5. Well, you can open the brackets and collect the like terms. You should get the answer. All right, so times everything by 15 or so, you should get it. I will leave that with you. Now that's the gradient, that's the equation of the tangent. As I said, you can solve that. Now we are taking a different question which involves trigonometry now. very important sums. They are, right? We have x equals to 2 cos t plus sine 2t, double angles please, and y equals to that. They want us to find the equation of the normal at t equals to pi over 4, right? That's a 45 degrees. Equation of the normal please, not the tangent. Let's go and find what is dx over dt, right? 2 cos theta differentiation please, minus 2 sine theta, right? And plus differentiation of sine theta is cos theta, so it's a 2 sine, 2 cos, isn't it? 2 cos 2t. Okay, chain rule, so we get the 2 in the front. We leave it there and then find dy over dt, see what happens. Differentiation cos theta minus sine theta, okay, and minus differentiation of sine theta is cos, we know, then we times by 2, so that becomes a 4. So it's a minus 4 cos 2t. That's what we actually get, right? Now this divide by that should give you the gradient. So I will write the gradient here, m equals to this divided by that, so which is minus 2 sine t and plus 2 cos 2t please. That's a plus sign, be careful. We have this now, this is the gradient. Simplification, as I said, I'm not worried because we just need to find the equation of the tangent there. T equals to pi over 4. Pi over 4 is a 45 please. Let's substitute that here. So we got minus sine 45 is 1 over root 2 or root 2 over 2, right? Minus t is a 45, 45 times 2, 90, cos 90 is 0, so that whole thing goes off. Divided by, denominator is a minus 2, watch, sine 45 is again root 2 divided by 2 or 1 over root 2. Cos 2t becomes 0. So this is what we got. I can cancel those 2's or even those 2 and I will be left with, well actually minus is gone, root 2 divided by root 2. 2 root 2, right? Root 2 over 2 root 2. So the gradient is actually a good looking number called half. Mind you, this is the gradient of the tangent always. You flip this over and change sign, right? We will get the gradient of the normal. So gradient of the normal, which is in green, is minus 2. That's all. Now we need a point. Okay, the point, we go back here and substitute t as 45. Let's see. 2 cos 45 is 2 root 2 divided by 2, so it's just root 2, right? Sine, that's 90 because t is 45, so sine 90 is 1, so that's a plus 1. That's the x coordinate. Root 2 plus 1 please, that's the x coordinate. Let's try and find the y coordinate. Cos t is root 2 divided by 2 minus this is 1, so that becomes a 2. So root 2 over 2 minus 2, that's the y coordinate. Root 2 divided by 2 minus 2 please. We have a point and we have the gradient. We can find the equation of the tangent, right? Let's see how it is done. Y minus y1 means that, so open the bracket with minus, so that's a root 2 divided by 2, minus times minus plus 2. So that's y minus y1 equals to gradient, which is minus 2, bracket x minus x1 minus, right? So it's minus root 2 and minus 1. Let's open the brackets maybe. Let's keep it like that. Here we can open the bracket or you times by 2 right through. Doesn't matter in any way. You know how to simplify the question now. Plus 2 equals to minus 2x minus times minus plus 2 root 2, and that's a plus 2. Okay, little bit messy, but we can solve this. I think the 2's on both sides cancel out, right? We can transfer this to the right hand side and say y equals to minus 2x plus 2 root 2, and transfer that fraction. It will be plus root 2 divided by 2. Actually, it's a half root 2, isn't it? 2x plus half x, right? That's what it means. So minus 2x, that's 2 times 2, 4, plus 1, 5, 5 root 2 divided by 2, y equals to. That's the equation of the tangent. Just be careful how you do those roots there, right? The last answer should look like this. And that was the question. Don't forget, please. T equals to pi over 4. One more question. Let's just take one question here. This is x equals to 2t plus 3. That's the y. Parametric equations, and what they asked us was find the show that the equation of the tangent is this 2y plus x equals to 7. That's nice. So we know exactly what we are supposed to get at t equals to minus 1. All right. So step 1, dx over dt, done, equals to 2. Step 2, dy over dt. So that's there it is, and that's a bit big one, 3t square minus 4. That's just a number. That's all. And the gradient, if you need, we said gradient is equals to the y answer divided by the x. So it should be 3t square minus 4 divided by 2, and we substitute t as minus 1. Watch that, that's what they asked us. That's the equation of tangent, please, not normal. So if we substitute a minus 1 there, that becomes a plus 1 if you open the bracket. So 3 minus 4 minus 1 divided by 2. That's what we have as the gradient of the tangent. We need the point, please. So let's go and check the parametric equations. Substitute t as minus 1. So minus 2 plus 3, which is a 1. Watch out. I can go wrong. Please check. That's a minus 1 cube, which is minus 1. That becomes a plus 4. So it's a 3. Right. 1 comma 3. A good looking fraction there, half. We can find the equation of the tangent. Y minus y1 equals to slope bracket x minus x1. You know how to solve the rest of it, right? So that's all. That's how you actually find the equation of the tangents. The trig ones are a little bit tricky, okay? Try this one with trigonometry. X equals to 5 cos t, that's a 4 sin t. You are supposed to find the equation of the tangent where theta is pi over 4, right? Very nice question. That's dx over dt, d theta now, right, is minus 5 sin theta. Differentiation of cos theta, please. Then dy over d theta is 4 cos theta, right? That divide by that should give me the gradient. So m equals to 4 cos theta divided by minus 5 sin theta. Guys, listen, pi over 4 for cos theta, sin theta, they both have the same values. So they actually go away. You are left with minus 4 over 5. That's the gradient. And substitute pi over 4 back in here and there. You get the point and use this gradient and find the equation of the tangent. Right? I will leave that sum with you to do, right? Because I've done one. Okay. This is the next one. X equals to 4 cos 2t. Y is at 3 sin t. They want us to find the equation of the normal. Show that it is 6y minus 16x equals to minus 23. That's nice. So we know exactly what we are supposed to get at t equals to pi over 6. By the way, pi over 6 is 30 degrees. So that looks good to me. The first one, we need to do the differentiation, right? Dx over dt equals 2 times 4, 8. So that should be a minus 8 sine 2t, right? Differentiation of cos theta, please.